This video contains the solutions to the line integrals of vector fields practice problems. For this first one, we want to compute the line integral f dot t ds, where f is the vector field xy, and c is the parabola parameterized by r of t equals 4t comma t squared, for t between 0 and 1. So when we set up the integral over c of f dot t ds, capital T here is the unit tangent vector, and ds is our parameterization by arc length. And as we talked about in class, it turns out that this is really just the same as the integral from a to b of f dot r prime, where that's a dot product, dt. So in this case, all we have to do is figure out the dot product of our vector field with our parameter, the velocity vector for the parameterization, dot those two vectors together, and then that will be a single variable Calc 1 style integral from, in this case, 0 to 1. So we're integrating from 0 to 1. Our vector field function is going to be x comma y, so that's going to be 4t comma t squared. R prime is going to be the velocity vector, which is going to be 4, the derivative of 4t is 4, and 2t, the derivative of t squared, is 2t. And then we're integrating that with respect to t. When we take that dot product, what we get is 4t times 4 plus t squared times 2t, and we're integrating that with respect to t. So now it's just a little bit of algebra and Calc 1. 4t times 4, that's 16t. T squared times 2t, that's 2t cubed. And so we're integrating that from 0 to 1. Antiderivative of 16t is 8t squared. Antiderivative of 2t cubed is 1 half t to the fourth. Plug in 1, plug in 0, and subtract. When we plug in 1, we get 8 plus a half, and when we plug in 0, we get 0. So this is just 17 over 2. Same type of problem, we've got a line integral f dot t ds, but this time we don't have a parameterization. We're just asked to use c being the line segment from 1 comma 1 to 5 comma 10. And so here we need to remember our standard parameterization for our line segment. And we want it to start at 1 comma 1 and go to 5 comma 10. So our x-coordinate is going to be t times the ending x value, which is 5, plus 1 minus t times the starting x value, which is 1. Y is going to be t times the ending y value, which is 10, plus 1 minus t times the starting y value, which is 1. When we work all this out, what we end up with is 4t plus 1 for my x component, and 9t plus 1 for the y component. So that means that the parameterization we're going to use is r of t equals the vector 4t plus 1, comma 9t plus 1. Now our line integral of f dot t ds is just going to be the integral. Our parameterization goes from 0 to 1, so our integral is going to go from 0 to 1. Our vector field f is y comma x. So this is y, and this is x. So we put the y component in here, 9t plus 1, and the x component here, 4t plus 1, because our vector field is y comma x, so we have y comma x. And then we dot that with r prime of t. So if r of t is 4t plus 1 comma 9t plus 1, r prime of t is just going to be the vector 4 comma 9. So we dot this with 4 comma 9, and we're integrating that with respect to t. So when we integrate, we got to do the dot product. So we get 9t plus 1 times 4 plus 4t plus 1 times 9. Work that out, we get 36t plus 4 plus 36t plus 9. That's going to give us 72t plus 13. Integrated that from 0 to 1. The antiderivative of 72t is 36t squared. Antiderivative of 13 is 13t. Plug in 1, plug in 0, and subtract. That's going to give us 36 plus 13 minus a bunch of zeros, so that's just going to be 49. Now in this example, we're given a field which represents a force at every given point. So the force at any given point x comma y is the vector y comma negative x. And we want to find the work required to move an object from the point 1 comma 2 to the point 0 comma 0. So what we're seeing here is that, and as we saw in class, the work is just simply going to be the the line integral of f dot t ds along this curve. So the first thing we need to do is parameterize this curve. So we're going from 1, 2 to 0, 0. So my x component is going to be t times the ending x value plus 1 minus t times the starting x value. And y is going to be t times the ending y value plus 1 minus t times the starting y value. So that's going to work out to be 1 minus t in the x component and 2 minus 2t in the y component. So my parameterization, r of t, is going to be 1 minus t, 2 minus 2t. So 1 minus t is my x, 2 minus 2t, that's my y. When we parameterize a line segment this way, the parameterization goes from 0 to 1. My vector field is y comma negative x. So that's going to be 2 minus 2t, that's my y, comma negative x, so that's going to be negative 1 minus t, that's my negative x. Now my r prime vector is just going to be the derivative here, which is going to be negative 1 comma negative 2, so that's the r prime, and then we integrate that with respect to t. We need to work out this dot product, so we get 2 minus 2t times negative 1 plus negative 1 minus t times negative 2. That's going to be negative 2 plus 2t plus 2 minus 2t. And that just works out to be 0. So the integral from 0 to 1 of 0 is just 0. Last one, here we have a force field F equals negative y comma x comma z, and we've got a parameterization that's given to us. So all we have to do is figure out the r prime vector, and then our integral, our work, will be the integral over c of f dot t ds, which is just going to be the integral, in this case, from 0 to 2 pi of f dotted with r prime of t dt. So the f vector is negative y comma x comma z. So negative y, the y is 2 sine t, so there's my y. So the x component of my force is going to be negative y, which is negative sine of 2t, or negative 2 sine of t. My x is 2 cosine t, so that means that goes in the y component of my force field. And then z is t over 2 pi. So that's my f. R prime is the derivative of these guys. So the derivative of 2 cosine t, that's negative 2 sine t. The derivative of 2 sine t, that's 2 cosine t. And the derivative of t over 2 pi, that's 1 over 2 pi. And then I integrate that with respect to t. Now some nice things are going to happen here. I'm going to get 4 sine squared of t plus 4 cosine squared of t, and then plus t divided by 4 pi squared. Sine squared plus cosine squared, that's just 1. So 4 sine squared plus 4 cosine squared, I can factor out the 4, and so I just get 4. So this is 4 plus t divided by 4 pi squared. Now when we integrate, we get 4t, and then we'll get t squared divided by 8 pi squared. Plug in 2 pi, plug in 0. When we plug in 0, we're just going to get 0, so this is just going to be 4 times 2 pi plus 2 pi quantity squared divided by 8 pi squared. So that's going to be 8 pi, and then 2 pi parentheses squared is 4 pi squared, so that's just going to be 8 pi plus a half. And that's our answer.